So yesterday in the lesson, we looked at a couple of parameters that affect how the graph of a quadratic function or a parabola is transformed. In yesterday's lesson, we actually looked at x minus p and we looked at plus q. And we realized that anything inside the brackets translated our graph left and right. Anything outside the brackets, the q, translated our graph up and down. So what we're going to look at today is we're going to look at how this particular coefficient a in front of our equation affects the graph. So I'm just going to switch to a computer applet and I'm going to adjust a. And I'm just going to slide this slider around. I'm just going to let you see that moving a makes that graph wider and makes that graph narrower. And sometimes it even flips it upside down. So what we need to figure out is, how do we know when that graph gets wider and how do we know when that graph gets narrower? So what we're going to do is we're going to start with this graph on the right hand side in your paper here. It's the graph of f of x equals x minus 2 squared. Or if we write it as an equation, it's y equals x minus 2 squared. So if you were to graph that on your calculator, you'd type in x minus 2 squared and put that in y1 and hit graph, and you get a graph that's like this. A couple of things we want to notice on this particular graph is that we have an x-intercept down here at positive 2. And that makes sense because this graph was translated 2 to the right. And we have a y-intercept over here on the left side at 4. Now, we're going to look at two different things. We're going to look at changing a to 2, and we're going to look at changing a to 1/2. So we're going to look at the equations. Y equals 2x minus 2 squared, and y equals 1/2 x minus 2 squared. And we're going to do that by going to the piece of computer software in a second so I can illustrate some things, and then we're going to come back and we're going to summarize what we've seen here. So if we go to the computer software, you're going to see that our original graph is this red graph, and when I change my graph to 2, which is here, whoops, you're going to see that the purple graph is our new graph. If you actually look at the arms of this red parabola, the parabola has actually been what we call compressed. It's like you grab the arms of the parabola and you push them in. The other thing that you're going to notice is that the y-intercept of the original red graph is at 4 here, and our new y-intercept is at 8. So what really has happened here is, instead of compressing our graph in, what we've really done is we've taken our graph and we've done what's called stretching it or expanding it. We've moved it upward by a factor of 2. We've taken each y value and we've doubled each y value. So this value at 4 became that value at 8. This value at 5 here, if I slide up, becomes that value at 10 here. So every y value was doubled. So that 2 in front, that a value, actually says, what do I do? What do I multiply every y value in my graph by? So if we go back to our sheet here, what we're going to notice is that if we compare the original graph to 2 of f of x, we've resulted in this graph being vertically expanded. We've taken the graph and we've expanded it upward. And what I want you to try and do to the best of your ability is to take these 2 points at 4 and move them up to 8 and quickly sketch in a graph of, and I'm going to take my pen and make that a little bit better. This particular graph right here is our graph of y equals 2x minus 2 squared. So we vertically expanded it, and it's been vertically expanded by a factor of 2. Whatever you've multiplied at the beginning is by a factor of 2. Another way to remember that is f of x is the same thing as y. If you look back here, y is the same as f of x. So this is saying 2 times f of x, or 2 times y, is what's happening. The y-intercept of our new graph is at 8. And it is double the y-intercept of our graph f of x. Our y-intercept went from 4 up to 8, so it doubled. So now we're going to look at 1/2. We're going to look at what happens when we change that. So now we're going to watch this purple graph as I transform this function down to 1/2. And you're going to notice that this graph has actually gotten wider. The arms of the parabola have gotten wider. And you're going to notice if we look at the, excuse me, at the y-intercept here, the y-intercept of 4 moved down to the y-intercept of 2. And that kind of makes sense. If we take our y values and we multiply them by 1/2, this value of 4, half of 4 is going to give us 2. If we go up here to 10 on our original graph, half of 10 is 5. So if I slide down, I'm going to see that I hit my graph right here about 5. So we've taken half of each of the values in our particular function. So if we go back to our notes, what we see here is that if we compare the original graph to the graph of 1/2 f of x, we've got a compression. Essentially what's happened is we've taken our graph, and imagine it's a balloon, and you hold the balloon between your two hands and you press down. Well, what happens to that balloon when you press down is the arms or the balloon gets wider. So that's what's happening to our graph. We're actually taking the graph and compressing it downward, and it's getting wider. And it's been compressed by a factor of 1/2. So the y-intercept of the original graph, when we compare it to that of 1/2 f of x, our new y-intercept is 2, and it's half of the y-intercept of y equals f of x. So if we actually look at this here, if we take these two values that we originally had at 4, if we move them down to 2 like this, then our new parabola is like that. And in fact, what I'm going to do is I'm going to grab a red pen here. This particular red graph is our graph of y equals 1/2 x minus 2 squared. So if we summarize what's happening in this particular situation, if we go down to point F down here, point F says if you compare the graph of y equals x squared to the graph of y equals ax squared, you're going to notice that we have a stretch by a factor of a. That value we multiplied by, it either stretches it upward or compresses it down, and we call those stretches. If that a value is greater than 1, then we have a vertical expansion. Our graph gets bigger. If our a value is between 0 and 1, meaning it's a fraction or a decimal, then we have a vertical compression. So you should be able to look at the equation of a quadratic function and decide, is it going to be expanded or is it going to be compressed? So if we flip to the next page in this particular situation here, what we're going to do is we've got the graph of y equals x squared in this situation here. So that's the graph we've got on the right side. And I'm going to go back to our situation here, and I'm going to create the graph of y equals x squared. So that purple graph is y equals x squared. I'm going to turn the red graph off. So now, if we look at our notes, it says, what happens in this situation if we make y equal -1 f of x? That's what that negative in front represents. So if we go back to our grid here, and I make this -1, what do you notice? Well, if I compare that to this red graph, what do you notice happens? Whoops. you're going to notice that, come on, all right, you're going to notice that this red graph was actually flipped upside down. It will be what we've called, it's been reflected. If you pick a couple of points here, this point at 4, if you go down to our purple graph, it becomes that point at -4. This point here at 5, if we go down, becomes that point at -5. So if A is negative, it actually reflects our graph. It actually flips it upside down. It doesn't change its shape as long as A stays the same. In this original graph, the red one, A has a value of 1, and in the new graph, the purple one, A has a value of -1. So A has stayed the same. The negative just reflects our graph upside down. Now, if I change A to -2, yes indeed, our graph gets narrower, or it's vertically expanded by a factor of 2. So the 2 still vertically expands our graph. The negative reflects it upside down. So if I take this point here at 4, if I reflect it, it goes to -4, and then if I double that quantity, that puts us at -8 right down here. So let's go back to our notes and let's summarize what we've done here. We have graphed each of these things, and now we're going to look at this table. The graph of y equals -f of x actually represents the equation y equals -x squared. It still has a vertex at 0 and 0. In this case, this particular graph, because if we look at it here, if we pick the points at 2 and -4 and -2 and 4, here's our graph of y equals -x squared. But because this graph opens downward, we now have a maximum value at 0. We have a highest point on this particular curve. The axis of symmetry is still x equals 0. And this particular graph, we took the original and we flipped it upside down. So we say it is reflected in the x-axis. If we look at -2f of x, that's y equals -2x squared. We still have a vertex at 0, 0. We still have a maximum value at 0. We still have an x-intercept at x equals 0. But that 2 not only reflects it, but so we are going to reflect in the x-axis, but we're also going to vertically stretch by a factor of 2. And knowing that that 2 is larger than 1, that means it's going to vertically expand our graph. So anytime, if we do this in general, if we have y equals ax squared, in this case we're going to have a vertex at 0, 0. Because a is positive in this, or negative, it says a is less than 0. So if a is less than 0, we're going to have a maximum value. We're going to have an axis of symmetry at 0. And no matter what value we have for a, it's going to be reflected in the x-axis, and it's going to be vertically stretched by a factor of a. So it could be 2, 3, could be a half, whatever it is. So again, if we compare -x squared to +x squared, what's going to happen to this graph? It's going to be reflected in the x-axis. Really important that you know that that negative quantity in front reflects this in the x-axis. If we summarize what we've written up here, if we compare x squared to ax squared, what we're going to notice is that we have a reflection in the x-axis and a vertical stretch by a factor of a about the x-axis. Okay, so that's a summary of what happens with a. Just like when we had P and Q yesterday, they affect our graph in some way, so does A.